Okay. Well, we already have the oil field producing oil and gas and water, and we are going to talk something about the gathering of those fluids and separating them and taking them to compliances to be sold or injected, or in the case of the water. Um, like I said, we already have a field producing good. We already know what we have simulated all the gathering system. We have simulated all the nodal analysis as well, and we are almost ready to put those nodal analysis in the trunk lines to the CPF or the flow stations. We're ready to put those fluids in there so that we can, like I said, separate them and taking them to the specs needed to be delivered. We still are in production, so we are going to describe the process of installed in a production system. So we have, in this particular case, we're talking about the gas lift system, where we have wells producing oil and gas and water and being lifted with gas. So all what we produce goes to the separated, where I separate gas from liquid in some cases, like in the Lake of Maracaibo, we separate gas from liquid. Then oil and water go together to a tank farm where the dehydration process takes place. So in there we separate the oil from the water. The water is, like I say, is polished so that we can put it back in the reservoirs. That's what we do. So in this particular case, like I said, we separate liquid from gas. Liquid goes to the tank farm. Gas goes to the compressors. The compressors, they increase the pressure. The formation gas is sold. It's been sold, or it's been injected, or you use it for generation. And part of the capacity, the compression capacity, is used to circulate gas through the wells to do the lifting again. So that's what we do. It's a closed loop, except for the formation gas that we need to get rid of it. And where we don't have gas lift, but we have pumping systems, the gas, we don't circulate gas, of course. So all the gas is compressed and used, sold or injected or generation. And in some places, this process of separating the gas takes place in a CPF. So we use the gas and we dehydrate in one spot. So you design your field according to your needs and the nature of your field. So, like I said, so we have equipment to separate first the gas. So, and we have separators where the three phases are involved. Separate the gas, and I separate part of the water also in that same equipment. That's what this is an example of that, where I separate water, oil, and gas. This is a separator that we tested in that oil field that I talked to you about, where we produce millions of barrels of water, and we wanted to separate part of the water and inject it up in the field so that I don't have to transport too much water to the CPF. That was an idea. The separator did a good job. So the water we separated here had a quality equivalent to less than 100 parts per million of oil. So if we compare this to what we were getting with the feed water knockout installed in the CPF with 100,000 barrel capacity at 5-hour retention time, so the 500,000 barrels being handled for that tank, that was a huge tank. So we could optimize the size of those and getting a better quality of water. I don't know what happened. We tested the separator. Everything was good. I don't know what actions the company took from that evaluation, which for me, it was a great idea to replace the feed water knockouts at the CPF. And this is a picture of vertical gas separators installed in, well, we have those in the Lake of Maracaibo where we have a good volume of gas, and also the lifting system is gas lift. You know, when after the feed water knockout separates most of the water, that water still has some oil in it. Like I said, in this particular field that I want to mention, or that I already mentioned, the water used to leave the feed water knockout with 2,000 parts per million of oil. So that's a lot of oil. So what we do is we send that water to skim tank where we use some chemicals, I don't know the name of the chemical. I don't remember. But what it does is try to put all the drops together and try to float them. So they go to the top, and then with a pump you recover it and send it back to the feed water knockout. And the water goes to flotation systems, and then go to the filter, to the pools, and then go to the injection system. All this is what made the city of tanks, because I think the solution to, or the option to reduce this city of tanks was to, first, from the reservoir point of view, I don't think we should have produced too much those wells. The rates were so high. Like I said, they had an aquifer, very active aquifer, and when they were producing high rates, the aquifer activates and the production gets so high. You know, and 96-98% of water, that's a lot of water. So I always thought that if we didn't produce those high rates with huge pumps, we could have avoided or reduced this lot of tanks. Like I said, it was like a city of tanks. But I never got involved in that simulation, but what they were always saying is that if they didn't produce those high rates, the wells were going to produce only water, and the oil was going to remain behind. That's what they say. I don't know. But anyway, so the process of polishing the water is a huge process that requires a lot of equipment, and they were very huge because of the volumes of water being produced. So once we put the water and the oil in a specs on compliances to be oil to be pumped in the pipelines and the water to be injected in this particular case, or in most of the cases. We need to try to determine how much oil in the spec I have, so that I know what I'm selling is the right volume. So there are two ways of measuring the volume of oil in the tank. One is the static measurements, which is the taking first. Well, first, after the feed water knockout, there is a process that I'm not describing here, but if you have heavy oil, you need to do a lot of things to put that oil in 0.5% of water cut. When it's light oil, so it's easier to put it in a spec. So maybe just putting the oil and water in a tank, like we used to do in Venezuela, and just draining the water, because the water from the oil was separated with the use of chemicals and not much chemical, because it was a light oil. But when you have heavy oil, the things change, and you have to do a lot of heating, a lot of things to separate or to put that oil in 0.5% water cut. So when we have the tank, we take samples, each one of some depth in the tank, and when we make sure that we have 0.5%, normally 0.5% of water cut to be pumped to the pipelines. And also we have the lease automatic custody transfer, which is a system where the oil gets in here, and they have some three-phase separators somewhere, and to help separate the rest. Normally, in a place that I was in the States, they had a wash tank, intermediate tank, and a pumping tank. And the pumping tank will pump here to get in the lag unit, and then everything was automated. Everything was flowing automated. So we have two clients here, so we send the amount or the volume of oil that each one of the client needs. And if for any reason, for any chemical failure or whatever, the water cut was not in specs, all the thing will return to the wash tank. I didn't draw it here, but you have a wash tank, like I said, an intermediate tank, and a pumping tank. So everything out of specs, it will go back to the wash tank, and the process will do it again. So this is what takes place I would say, to get the fluids in conditions to be sold or injected, and to be measured or fiscalized, so that we can know exactly what we're selling in an oil field. All the process in this oil field that I told you about, big, huge, 300 wells producing a lot of water, we had everything simulated, and we have an optimization software that every money, according to the changes in the wells, it will optimize the electrical intake for each one of the wells according to water and things that are being produced. Okay, talk to you later. Thank you very much.